Hey guys, what I'm going to do today is go through problems 3 to 5, just so you can check your work, and if you were stuck on any of these ones, hopefully this will help you out. So taking a look at number 3 here, it says a cashier has 25 coins consisting of nickels, dimes, and quarters with a value of $4.90. So we have nickels, we have dimes, and we have quarters. I'm just going to abbreviate those. So in total, we have 25 coins. So if we add our nickels plus our dimes plus our quarters, we should have 25 total coins. So there's one of our equations. The next one has to do with the values of the coins. So we know that all of them add up to $4.90. And the value of a nickel is 5 cents. The value of a dime is 10 cents. And the value of a quarter is 25 cents. Okay, so there's two equations. And then the next sentence says, if the number of dimes is one less than twice the number of nickels. So let's think about that. The number of dimes is, we know is in math means equals, so the dimes equal one less than twice the number of nickels. One less than means something minus 1. Twice the number of nickels means 2 times n, so we have 2n minus 1. So there's our three equations. 1, 2, and 3. Okay, so next part we have here is we need to figure out what we're going to do to get one of these variables. So what I kind of lean towards first here is substitution. So I see that d equals 2n minus 1, so I plug that in for d. So I'm going to plug in 3 into equation 1. So when I do that, I end up getting n plus 2n minus 1 plus q equals 25. When I combine like terms, I get 3n plus q. I'm also going to move the minus 1 to the other side, so I'm going to add 1 to this, so that'll be 26. So there's an equation right there in terms of n and q. So now the next thing I'm going to look at is I'm going to look at my equations. I know I have to use equation 2 somehow, because I haven't used that one yet. So I'm going to use equation 2, and I'm going to use equation 1 here, and I am going to try and get it in terms of n and q, or I'm going to try and eliminate d. So if I'm going to try and eliminate d, okay, I'm going to use 2 plus 1. Equation 2 is 0.05n plus 0.10d plus 0.25q equals 490. And 1 is n plus d plus q equals 25. My goal is to eliminate d, because then I'll have it in terms of n and q, just like this one. Okay, so now if I want to eliminate d, what I'm going to do is I'm going to multiply the bottom by negative 0.10. So when I distribute that to all four terms, I get negative 0.10n minus 0.10d minus 0.10q, and then you can multiply 25 times negative 0.10, and you get negative 2.5. Okay, so now I'm going to add these two together. So when I do that, I end up getting negative 0.05n My D's cancel out. I have plus 0.15Q equals, and then I have 490 minus 250 would be 240. Okay, so now I'm going to highlight in red the two equations that I have that are two variables. 3n plus q equals 26. And negative 0.05n plus 0.15q equals 240. So you can do whatever method you want to use here. You could do elimination. You could do substitution. I'll use substitution just because we used elimination last time, just to mix it up. So I'm going to take this one, and I'm going to solve for q. So I'll do that in the left corner here. So to get q, I'm going to subtract 3n from both sides. So I have q equals negative 3n plus 26. Now I'm substituting this in for q here. Okay, so if I do that, I'll bring that over here. I have negative 0.05n plus 0.15 times q, which we just found is this. And that equals 240. Sorry, it's a little sloppy. It's hard to write on the iPad sometimes here. Okay, so now it's a matter of just distributing and solving for n. Okay, so I have 0.15 times negative 3. So we have negative 0.45n. And then I have my 26 times 0.15. So I have 390 equals 240. So now I combine like terms. So I have my negative 0.05 plus my negative 0.45. So we have negative 0.5n. And I'm also going to subtract this over to save me time. So 240 minus 390. So I have negative 1.5. And now I'm almost done solving for n. Divide by negative 0.5. So we have n equals 3. Okay, so that was a lot of work to get n, but the rest of them should be easy. So we can definitely get q pretty easily here, or we could get d pretty easily. So it doesn't really matter what you plug in first. I'm just going to choose to look at this here. This is n. If I plugged in 3 for n here, that would be d equals 2 times 3 minus 1. Well, 2 times 3 is 6. 6 minus 1 is 5. So we have 5 dimes. And now we know that we have 25 coins total. So if 5 of them are dimes and 3 of them are nickels, that means we have 8 total coins so far. That means we must have 17 quarters. Okay, so we would have 17 quarters, we would have 3 nickels, and 5 dimes. Okay, so taking a look at the next two. So for number 4, it says a theater has tickets at $6 for adults, $3.50 for students, and $2.50 for children under 12. A total of 278 tickets are sold. Okay, so we have 3 different types of tickets here. We have the adult tickets. We have student tickets. So I'll call the adult ones A, student tickets S, and children's will be C. So we know if we add all of those tickets up, we have a total of 278 tickets. We also know that 278 tickets were sold for one showing, and the total revenue was $1,300. So if the total revenue was $1,300, this is similar to the value of the coins. You need to put the price of the ticket in front. So if we add up every one of the adult tickets for $6 each, plus all of the student tickets that were $3.50 each, plus all of the children tickets that were $2.50 each, we should get a total of $1,300. And the last sentence here will give us our final equation. If the number of adult tickets sold, okay, so if the number of adult tickets sold, so A, was is past tense for is, so that should be equals 10 less than twice the number of student tickets. So 10 less than means something minus 10. Twice the number of student tickets means 2 times S minus 10. So now I have my three equations again. The solving is very similar to the last problem that we did. There's obviously multiple ways you can do this, but the first thing that typically sticks out in my mind here is that we should use substitution with 3 into 1. So if we do that, I'm going to take this and substitute it in for A here. So when I do that, whoops. I get 2S minus 10 plus S plus C equals 278. So now combining like terms and moving the negative 10 to the other side, I have 3S plus C equals 288. Okay, so just like the last one, I'll highlight that in red because I know I'm eventually going to have to use that equation. Okay, so now I'm going to use the other equation. I'm going to use equation 2, and I'm going to use equation 1. And I'm going to add them together. But in order to get an elimination, I'm going to have to multiply 1 by negative 6. Why am I trying to eliminate A? Because if you look at this one right here, it's in terms of S and C, so we don't want A. So if we have equation 1 and 2, so there's equation 1, equation 2. Okay, I'm going to multiply the top one by negative 6 to get the A's to eliminate. Okay, so 278 times negative 6 is negative 1,668. And now I add straight down. My A's cancel. I have 350 minus 6 would be negative 250 S. And then I have 250 minus 6C would be negative 350 C. And that equals 1,300 minus 1,668 would be negative 368. Okay, and there's my other equation. Okay, so you could do elimination here. So with this one, I'll do elimination just to kind of mix it up. But if you like doing substitution, just like the last one, definitely do that. So I'm going to use my two red equations. 3S plus C Okay, so what's the easiest elimination? Probably multiplying the top by negative 350, because then the C's will eliminate. So the first thing we have to do is we have to distribute 3 times negative 350 would be negative 1050. And I accidentally made a mistake there. You don't want to multiply by negative 350. That's my fault. You want to multiply by positive 350, so it'll actually cancel out. Sorry about that. So then multiply 288 times 350. And then we can add straight down. So now we have negative 250 plus 1050 would be 8s. The c's cancel. And we have negative 368 plus 1008. So 640 divide by 8. So S would equal 80. So there are 80 student tickets sold. So there's one of our answers. And now I need to get the other two. Well, it's the same as the last problem. It's pretty easy if we just use equation 3 here to get the adult tickets. So we know A equals 2 times the number of student tickets minus 10. Well, 2 times 80 is 160. 160 minus 10 would be 150. So we sold 150 adult tickets. And if you look at the last part here, or equation 1, sorry, if you add them all up, you should get 278. Well, 150 plus 80 would be 230. So we need 48 more tickets to get 278. So that must mean that the number of children tickets sold was 48. Okay, so there's problem 4. And now our last one here. We have Roy, Sally, and Jeff, and they're driving a total of 50 miles to work each day. Okay. Sally drives twice as far as Roy, and Jed drives 10 miles farther than Sally. Okay, so we have Roy, I'm going to say is R, the number of miles that Roy drives, the number of miles that Sally drives is S, the number of miles that Jeff drives is J. And we know they drive a total, if you add them all together, of 50. So there's our first equation. Our second equation comes from the second sentence here. Sally drives twice as far as Roy. Okay, so Sally drives twice as far as Roy. So our equation is going to be S equals 2R. Why it's S equals 2R and not R equals 2S is because if Sally is driving twice as far as Roy, let's say Sally drives 20 miles. In order for these two to be equal, if she's driving twice as far as Roy, that means Roy would drive 10 miles. And the only way that these two could be equal to each other is if we multiply Roy's miles times 2. So that's why that equation works there. And then our last equation here, Jed drives 10 miles farther than Sally. So there's a couple different ways you can do this one. But we have Jed, and he's driving 10 miles farther than Sally. So if he's driving, let's say, 20 miles, and how many would Sally be driving? Well, if Jed's driving 10 miles further, okay, so she would be driving 10. What do we have to add to Sally's to make it to equal to Jed's? We would have to add 10. So there's our equation there. Okay, so now we need to actually solve these. Okay, so taking a look at these first three, there's a lot of different ways you can do this, but again, my mind kind of always leads me to do substitution when I can first. So the first thing I see is S equals 2R. So I'm going to go to the first one and plug that in. So I'm going to plug 2 into equation 1, and I'm kind of already regretting writing those equations so big. So if I do that, I still have R. I'm not going to have S anymore. I'm replacing that with 2R plus j equals 50. Combine like terms, I have 3r plus j equals 50. Okay, so now if I take a look at this next one, well, what if I plug equation 2 into equation 3? Why I would want to do that is if I do that, if I take this and plug it in for s, then it'll be in terms of j and r, just like the other equation. So I'm going to do that. And now I'm going to have j equals 2r plus 10. And I'm going to move it around a little bit just so it looks like the other. Actually, I'm not going to do that because then we could just do substitution. So just leave that how it is for now. Here are my two equations. Okay, so now we can do substitution. What I was thinking originally was move this 2r to the other side, so it's negative 2r, and then you could just do elimination by multiplying one of them by negative 1 to eliminate the j's. But substitution is actually easier in this case. So I'm going to take what j equals and plug it in for j. No distributing required. So 3r plus j, well, we know j is 2r plus 10 equals 50. Combine like terms. Subtract the 10 over. So we have r is equal to 8. So we know Roy drove 8 miles, or drives 8 miles to work each day. So now to figure out what Sally drives, well, Sally equals 2 times r. Well, we know that r is 8, so Sally must drive 16 miles to work each day. And we know that they drive a total of 50 miles. So if we think about this, 16 and 8 would be 24 miles. How many more miles do we need to get to 50? We would need 26. So that means that Jeff drives 26 miles to work each day. Okay, so hopefully going through these problems will help you to complete the assignment if you didn't already complete it. If you have any further questions, just let me know. You can send me an email. And